last chapter was about, chapter 6, solving. Yeah, we were talking about solving linear equations. Now we're talking about inequalities. And with the last class, what's an inequality? It's any statement that has which symbols? Can you guys read these for me? Greater than. Greater than or equal to. And the least common one? Not equal to. Those are all inequalities. We're going to deal with the first four the most, but we are going to deal with this one as well occasionally on some exemption problems, which we're going to get to more deeply as we go into this chapter. Now, I'm thinking to myself, hold on. You're telling me, Mr. A, that chapter 7 is all about these four symbols? Yep. Now, this first lesson, if you turn the page, this first lesson is solving inequalities by using addition and subtraction. So 7-1, solving inequalities using addition and subtraction.
Do you like that better?
It's a little harder to write on.
It looks like a chalkboard.
And that's the effect, I guess, that it has, yeah. I miss chalkboards. I don't miss all the powder when you clean them up, but other than that, they're very functional. In fact, randomly looking up this video on a Harvard professor, because they post some of their videos online of him teaching, he has a whole wall full of chalkboards. I think he had 6 of them, and they're the long ones, so they're about that size each. And it's so cool. I thought it was so amazing. You know, chalkboards you write on, you got to erase it to write again on it. So he would use it all up, and then he would spin it, and it'd be a fresh board. So he had not 6 of them, but 12 of them. And he's just like flipping them over. Goes to the next one, flips it over. I was just like, that's so cool.
When he has to clean it all.
You think he does it? He doesn't do it. Yeah, they get someone to clean it up for him.
I have 3 walls in my room.
Mm-hmm.
That will,
Chalkboards?
Yeah, they're all chalk.
Really?
Yeah, we just it's like a paint thing.
Yeah. That you can make it like a chalk. Oh, that's right. They can do that.
Yeah, Miss Brinson's.
Yeah, Miss Brinson had a chalkboard wall. Well,
You think you can do it to this wall?
Yeah.
Is it still there?
That is one of my favorite things about chalkboards or whiteboards. This one is probably my smaller screens. Even the smartboard is a little bit longer. So unfortunately, I can't scroll down. I have to add another page to keep going. So it's a little bit harder to do, but we'll get used to it. Okay, let me give you an inequality here. 29 plus g, and we'll just go less than or equal to 68. This is an inequality because it has a less than or equal to sign. And I want you to go ahead and solve that. You're like, I can't solve that. When you solve an inequality or an equation, what's your whole goal? To get the variable by itself. So how do I get that one? Does anyone know how to do this one? Josh?
It's the same thing as an equation.
Yep.
It's like minus 29 on both sides.
Yeah, and especially for this lesson, for the most part, it's going to be exactly the same. So nothing new here. So again, g is less than or equal to 39. Okay? Now, that would be our inequality solution, but I have to ask you what that even means. Okay, when we're dealing with equations, how many solutions do we normally have? 1, normally. You're going to get more that have more solutions, but normally you have 1. How many numbers fit this inequality? How many? An infinite number. How would you describe those infinite numbers? You would say it's any number that is, less than or equal to 39. So it could be 38, 37, 36, all the way down into the negatives. But it can also be 38 and a half, 38 and 3/4, 38 and 1/6, 38.25. It's going to be all of those numbers there. Okay? Now I'm making a point of that for a reason. Okay, normally this is how you write your answers. G is less than or equal to 39. But I have a question, and I'm going to do it after an illustration. Back in the day, they used to sell eggs, but they didn't sell them in dozens. You just go to the market. Okay, it's a market, and you'd ask for however many eggs. So like, I'm thinking to myself, I love eggs, so I'm going to get like, today I'll get 8. Okay, I'm not going to eat them, well, no, I'm not going to eat them all, but I want 8. So I go to the egg, can I call you egg farmer?
Yes.
No?
Do it.
Harriet, will you accept the term?
Yes.
Okay, fine.
Yes.
Beth, will you take egg farmer? She's an egg farmer, and she's proud of it. So, Beth, I go to Beth, and I'm like, Beth, can I have 8 eggs? And she says, sure. And she gives me the eggs, and I give her the money, right? There's only one problem. I'm not very good with my numbers. And so one day I wake up, and I'm thinking, I'm a little hungrier than normal. I want 9.5 eggs. Please. Yeah, you can. You just, like in half. Okay. How long have you been egg farming? And you can't split an egg? Sorry, but I'm not trying to. You're being a good sport so far. Can I really ask for 9.5 eggs?
You can.
No.
You might not get it.
Yeah, I'll ask all day and I will not get it. What about a hard-boiled egg? I don't want I want just a fresh half an egg plus 9. Okay, I don't do that. How about this? Maybe it's how I worded it. Can I have instead? Okay, let's get done with the 9.5. Can I do 7/5 eggs? Why not 7/5?
Too hard.
Does anyone know what 7/5 is? Sorry? Okay, 1 2/10 or 1.4, or not 2/10, 1 2/5, 1.4. Okay, I can't really do that, so listen to me carefully. If you were in that time asking for eggs, what numbers were you using to ask for those eggs? Like, what numbers were you using? You were not using fractions. You were not using decimals. You were using... I think I'm going to accept whole numbers or even natural numbers. Natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? You can go as much as you want, but you didn't ask for 1.5. I mean, would you? No one does that. It's the same thing as this. How many people can fit in this class? I think 22.5. I really do. That's what guys, that's ridiculous. It's 33 1/3 can fit in here. So we get the 33 in here, and then...
1/3 of a person.
No, we just get a third size person. Okay. Get my son. The whole point is this. Sometimes you use fractions. Sometimes you use decimals. Sometimes you use wholes or naturals. But in this problem right here, am I making any distinction? Am I saying you have to use one or the other? No. So this is what I want you guys to get used to writing. It's called set builder notation. So this is going to be important. This is the most basic way you can use set builder notation. Later it will be more complicated, but if you can understand this, it's great. That first problem, the answer was x is less than, greater than, less than. It was, or g was less than or equal to, what was the number? 39. Thank you. I just wanted to use that same number. Okay, g is less than or equal to 39. This is how you would write it in set builder. Did I have a restriction on what kind of number g can be? No, I didn't say it had to be a whole number or an integer or a rational. I didn't say any of that. So this is the set builder notation I want you guys to get used to. G is any number such that g is less than or equal to 39. I love the faces I'm seeing here.
That one, I can't remember what it's called. It's like, what's the thing where you put 2 lines?
Oh, absolute value? It looks the same, but there's only one of them. So maybe you can think of it that way. I'm going to read it again out loud, and then I'll have you guys read it with me so you can get used to how you say it. Okay, G is any number such that little line means such that, G is less than or equal to 39. Okay, so that's how you say it. I'll say it one more time. G is any number such that G is less than or equal to 39. You guys say that with me? You ready? G is
Any number such that G is less than or equal to 39.
good. All right, how many of you are okay saying it? All right, so that's a good step. The reason I put this here is because I'm making it clear to all of us now, and hopefully as you get used to it, you'll be like, okay, I get it. That G can be any number. It could be a fraction, a decimal, a whole. It could be 0. It could be negative. It could be any number. Okay, are we talking about eggs right now, you think? No, because eggs aren't, you don't get negative egg. Can I get negative 5 eggs, Beth? She's like, okay. Take away the, can you get my eggs, buy my eggs back? And we have that sort of usage, but even then,
Returning.
yeah, returning things, that came into play. But here, I'm making it very clear, any number, okay? All right, let's do another example, see if you guys can get it. Example number 2 on page 386.
Why are you making it so clear if it's kind of like inferred?
Yes, that's actually a good question. Let's work this one out. I'm going to give you where it's going to make it clear for you more clearly. Okay, so example 2, because I see your question, that's good. But I'm going to wait for this example. So 13 plus 2z is less than 3z minus 39. All right, there are a couple ways to work this problem, a few ways to work this problem out. What would you do if you're trying to do this problem? Help me out. Eli?
Take away 2z from both sides.
All right, I'm going to subtract 2z from both sides. I get 13 is less than z minus 39. All right, from here, we should all do the same thing, but what would you do next? How do I get z by itself? Yep.
Add 39.
Add 39 to both sides. And I get 52 is less than z. Okay. Huh?
Yeah.
How do I write that with set builder notation? Because right now, 52 is less than z. That is true. But don't I have to say like z is any number such that? Josh?
Well, z is any number such that z is greater than 52.
Whoa.
No.
You mean this? Okay, I have several questions because I'm looking at thinking to myself, what? Okay, how many of you were okay with 52 is less than z? Like you got that and that's no problem? How many of you are okay with this right here? All right, how in the world did we go from 52 is less than z to z is greater than 52? Like that just totally threw me off. Okay, ready guys? Let me point out some things. All right, looking at this, which side is greater? Which side is greater? Z is greater. We're okay with that? On this, which side is greater? Z. So did we change the meaning of the inequality? No, we changed the orientation of it. All right, so everyone okay with this? Okay, did you get this as well? Get used to writing it. Soon you'll get it down. You'll be like, okay, I get it. And now I had a good question. Mr. A, if I just wrote it like this, greater than 52, don't we kind of already know that it's any number, right? And that's a good question. And the answer is yes. I guess I'm going to have to go here. You're going to get this later on. Please don't worry about this too much. Don't be like, oh, Mr. A, what are you doing? Just kind of listen to me. Soon you're going to be able to do this. Z is an element of the set of rational numbers such that Z is, what was it, less than, greater than?
Greater than, yeah.
52. You're going to get this. And you're like, what in the world did you just write? Okay.
It means that Z has to be a rational number?
Yeah, it's going to be that Z is going to be a rational number. Okay? So can Z be any number out there? And the answer is no. It can be a rational number. But what? There are no other numbers than rational numbers. What's the other type?
Irrational.
Irrational numbers. And they are real. Sorry. Oh, actually, that's true. Okay. Rational numbers and irrational numbers are all part of the real numbers. And that's a little bit of review from before, but now I'm making it clear on what I'm talking about here. Or I could say, remember our egg example? I want to buy Z amount of eggs. So Z is going to be part of the actually, you don't do it that way. The natural number such that Z is that. I'm talking about natural numbers. I'm not talking about fractions. I'm not talking about even zero. I'm talking about this is how many eggs I can buy. Beth has 52 eggs. What's the most she can buy? Or what's the most I can buy from her? 52. I can buy 52 or anything below that. Am I going to buy negative? No, that's not buying, that's selling.
I'm sure it's anything above 52.
Oh, yes. I'm sorry. I thought there was a less than. It's, anything above. So she has a minimum. You cannot buy less than 52 eggs. So what can I buy? 52 or above, or actually 53 and above. Yeah, there you go. Yes.
Why does the R have two?
That's the symbol for rational numbers.
Per paragraph.
Now, there are other. That's for rational there. I used to write like that.
And then what's a normal R? Real?
Yeah.
Is that real number?
No, the real numbers, I'm trying to remember. It might be that. I'm going to look that up. What does real number? That's just an R. Oh, range.
Range.
Range. Forgot.
Yeah.
That's just an R.
Whoa.
Oh, yeah. Ready?
Just erase a line. What in the world?
Goodbye.
What? That's so helpful. Because the other one you couldn't see where you were drawing it. But
And this is very precise. So, like, if I want to erase, I don't think I can do it, but if I just want to erase that, I can do it. Like, I could be very precise. Very. Or my favorite part. Goodbye. Okay. Thank you. Okay. What were we doing? Let's go back to that last answer. The set builder notation. Z. That might not work. Z is any number such that Z is greater than. I think I finally got that down. Okay. How do we graph this solution? Do you guys remember how to graph it? Graphing is just a number line right here. So you start with the 52. All right, what kind of circle goes on 52? Open circle. Does anyone know why it's open and not closed? Yeah, it's only greater than. There's no equal to sign. And then where does the arrow go, left or right? It goes to the right.
Right.
Yeah, there are two ways to figure it out, and two ways you really need to get. Please listen up. Z is greater than 52. What numbers are greater than 52? All the numbers on the right side. Or if the variable is on the left and the number's on the right, you just follow that arrowhead. It's pointing to the right. So there are two ways to look at it that way. Okay? All right. So you should be able to write set builder and graphing it. Okay, last little part here. Page 386. If you're not on there, please go there. Do you guys see that little chart that has inequalities at the top? Okay, ready, guys? You're going to be translating again. You're translating sentences into inequalities. So the inequality symbols, what's this one right here? This one's greater than, right? What phrases can be translated into the greater than symbol? So look at that little chart. More than or greater than. Does that make sense? I hope that's clear. More than or greater than. What about this one? This is the less than symbol. What phrases can be translated into that? Fewer than or less than. Greater than or equal to. These are the harder ones. Wait, greater than or equal to? At least? Wait, at least? No less than. Wait, did they mix it up? Because I'm pretty sure it's switched, right? Okay, these are the hardest ones to get down. These two right here. Because doesn't this look like it should be no more than or at most, but it's actually not. It's at least or no less than. Okay, why is this symbol really at most? Oh, sorry, at most. Why is this one at most? I know, that's my fault.
That's a good statement.
This one's
'Cause it's
at least, and this one's at most.
Because it's less than or equal to, so the highest it can be is equal.
Okay, right here, this one's saying at least. Okay, this one's at least. We're good on that? So that's saying that your smallest number is whatever's after. So let me give you one real quick. Let's change this one real quick. Okay, I could translate this Z is at least 52. What does that mean? That it could be any number that is 52 or up at least 52. Like, have you ever been to a ride
Yes.
at an amusement park that says at least 52, something like at least 52 inches? So what does that mean? 52 or above. At most. I don't think there are many rides that are at most, but they're,
Like little kid rides.
yeah, or on the play place at Chick-fil-A, it says you need to be at most 42, 48 inches, whatever. And that really bums me out, by the way.
Yeah.
Can't even play anymore. So that means you can be up to that height, whatever it is. Okay, example 4. Let's see how this plays out with our work. Example 4. All right, we're going to translate that sentence into a mathematical expression. All right. Yeah.
Could a roller coaster be at most because if you're too tall,
You'll
and
smack.
you get chopped off by the thing coming off or something?
Yeah.
You do get scared of that roller coasters though.
Yeah, and they actually design it so that people who are pretty tall with arm stretch would not hit it. Because, yeah, I'd be worried about that too. Like, it's like
There's like poles that hold up other stuff, and then I feel like if you reach far enough, you could touch it.
Don't touch it.
Scary.
Don't ever do that. No.
Tallest
Yeah,
man.
I knew a person who said that they reached up and hit something, and I thought to myself, that's impossible, because that arm would no longer, or at least that finger, would no longer be a part of you. It would have been taken away. So I don't think it happens, but yeah, I think you can have, like, if you're Yao Ming, you guys know who Yao Ming is? Tall basketball player. 7 foot with outstretched arms. You'd be
And when
tall.
you're going like up things, they sometimes have like the stairs on the side. Like,
Oh,
you
yeah,
can
yeah.
stop. Like, you can,
Keep
or, like,
your
drag your
hands
foot on it.
inside the ride at all times.
Or like put your foot out and drag your foot on it.
I'm going to talk to your parents after this.
You do that? No, I've never done that.
Oh,
Because
no one get an idea. Okay. Example 4, 3 times a number is more than the difference of twice that number and 3. How do you write 3 times a number? Let's write 3x, 3n, 3x, 3s, 3t, doesn't matter. 3 times a number is more than. How do you translate more than? Greater than. And this next part I hope you understand. Then the difference of twice that number and 3. So what's difference refer to? Difference is referring to subtraction. So the difference of the difference of twice that number and 3. Yeah, it'd be the difference of 2x minus 3. So that's your inequality. Sorry? No, it's not. And the hardest part about those problems are going to be that more than, less than, at most, at least. That's where they're going to try to get you. All right, then here to solve it, I want you to write your answer in set builder notation and to graph it. Okay. All right, is that set builder? No? Okay, ready? Here, I'm going to make it tough for you. That's set builder. X is any number such that x is greater than -3. Okay, that's set builder, and then you have to graph it. And on your homework, some of your problems you graph it, some of them you don't. So that's okay. So you start with -3. What kind of circle goes on -3? Open. And the line goes to the?
Wait, how do you know if it's open or not?
Yeah, if it has an equal to, then it's closed automatically. If it just has the inequality with no equal to, open. And that would be your answer to example 4.
Hey, how do we graph the equal, like, not equal to?
Oh, that's a nice one. I'm done with this here. So if you had x is not equal to 3, you draw an open circle on 3, line going in both directions. Because what can x not be?
It's
It can be
everything
anything
But 3. So that's where we're going to put the 3.
Was there with the arrow on the last one?
To the right, I believe.
Oh, that makes sense.
Yeah. So it can be any number except for 3. It cannot be 3. Or whatever number it's not equal to. By the way, guys, this is the first of the lessons of this chapter. These are the basic ones. We've done these before. Other than step builder, everything else is pretty much the same. It gets tougher when we start dealing with absolute value. Some of the toughest lessons you get this year, absolute value graphing.
Are we gonna come back to like coordinates and that trigonometry?
I still think about like what I need to do with that. So it's in the back of my mind. It's awesome. It's such a good. It really is such a great lesson.
Well, why didn't we do it?
Because we're not ready for it at that point to be efficient. Not yet. To be efficient, to be like super efficient, to get through it and really understand it.
We're gonna get through this.
Yes, I hope. I hope. All right, your homework tonight. Here. It's okay. You'll get it again. You'll get it again. So 17 to 37 odd. 388, 389.
At least you're not killing us on the first day. I appreciate that.
Please read the instructions. The first set of problems want you to graph the solution. The rest of the problems do not graph the solution unless you want to. But
Extra credit?